I want to give you a quick review of graphs and graphing, specifically just graphing lines. First, I want to say you might wonder why math instructors are always making a big deal out of graphing. Well, it turns out graphs are very powerful in our lives, and graphs can give you a lot of information in a single glance. If you want to pause this video and just look at the two graphs that are on the screen right now, just ponder them and think about them. What information are you getting just by glancing at each one of these graphs? All right, so you've had a chance to take a look. On the graph on the left, we see it's the value of Sarah's car. So somebody decided that they wanted to see what the value of their car was over the years. And if this person had written this data as a paragraph of text to explain it to you, you wouldn't have quite grasped the idea that the value of Sarah's car went down so quickly over the years. The graph, we can just glance at it and it tells us everything we need to know. Now on the right is another graph, and it's sort of meant to be humorous, obviously, but it makes you stop and it makes you look at these things, and you can tell things just by a quick glance. Here's another example. So let's just say that you're learning about graphing, and each day you're going to give yourself a short quiz to see how you're doing. So you decide to record the results in a table, such as the one on the left. So on the first day, you only remembered 3 things correctly about the graph. On the second day, you remembered 4 things correctly, and so on. So you could just store this stuff in a table to record all the information. Now, if you put those same results on a graph, look at the graph on the right, you can very quickly see that you're improving, and actually improving pretty quickly. So graphs give you a lot of good information very quickly. All right, so now back to the work of actually creating our own line graph. When you want to communicate your own data, maybe you collect your data in a table and then you put that on a graph. We're going to look at this a little bit more algebraically, but the same techniques would apply if you're trying to create your own just from data that you collected. There's 3 common methods that we look at for creating a line graph. One is we can create a table of values, plot the points, and then connect the dots. Or we could use the x and y intercepts, or we could use the slope and the y-intercept. So I'll go quickly through each one of these. First of all, create a table of values, plot points, and connect the dots. So what does that all mean? So you're going to start with an algebraic equation, and let's say your teacher says, okay, here's your equation. I want to see that as a graph. So here's what we're going to do. We're going to make ourselves a table, and the x and the y represent coordinates on our graph. The x is the x coordinate, and the y is the y coordinate, and together that's a single point on your graph. You could think of it as a latitude and longitude if you're looking at a GPS. So the trick to creating a table of values is that you just pick a number out of a hat, substitute that value in for one of your variables, and then solve it for the other variable. So I'm just going to pick 3 random numbers, and I'm going to make them small numbers because I don't want to do a lot of work with arithmetic. So here's my 3 numbers. I'm going to use a -1 and a 0 and then a 3 for x. For each one of those, I'm going to plug that value into the equation and solve for y. Now why 3? Why is that some sort of magic number? Why 3? Why am I doing 3 values? Well, you can always make a line. If you just put 2 dots on a piece of paper, you know you can just set your ruler down and you can draw a straight line. Well, what if we make a mistake in calculating one of those 2 dots? Well, that's why we add a 3rd dot. It's called our safety point, because if you put 3 dots on a piece of paper and one of them is out of line, then you can tell that you've made a mistake in at least one of those coordinates. All right, so the first value, we're going to substitute a -1 into our equation for x. Now we have to do a little bit of work. So we're going to multiply the 2 by the negative 1, which of course gives you a negative 2. So now we have y minus 2 is equal to 3. And you could probably figure this out without doing any algebra, but if you did it algebraically, you would add 2 to each side of the equation, and then y equals 5. All right, so now we have our first pair. Our first point is the point negative 1, 5. Let's go to the second one. Substitute the 0 in for the x. Plug that number in. Work the arithmetic, and you get y is equal to 3. And finally, our third value for x. Plug the 3 in for x in our equation. Solve it for y. And we get that y is a negative 3. So now we have 3 points. We're ready to construct our graph. So the first task is just to draw our set of axes. So a horizontal line and a vertical line, that's your x and your y axis. And then we have to scale it, because if we want somebody looking at this graph to understand the scale of the graph, we kind of have to provide them some tick marks and a scale. In this case, my numbers are very small, so each one of those tick marks is just going to represent 1 unit, and I'm going to put some numbers on those tick marks just to show somebody what those values are. All right, so let's take our first point. Our first point is at negative 1, 5. So we're going to go to where x is a negative 1, and then we're going to go up 5 and mark a dot. The second point is 0, 3. So we're going to go where x is 0, and then go up 3 from there. And the third point, where x is 3, we're going to go to where x is 3 on the x-axis, and then we're going to go down 3 units from there. Now we have our 3 points. Excuse me. Lay down your ruler, draw a straight line, and you're done. So that is creating a table of values. So once again, very quickly, you pick any 3 values you want for x, plug each one of those in and solve for y. That gives you 3 points. Plot those 3 points on your graph, draw your line, and you're done. Let's go on to our second method using the x and y intercepts. This is really very close to the first method. We're really still going to create a table of values, but we're going to use 2 special values. We're going to put in a 0 for x, and that's in my first line in the table. And then we plug that into our equation, and we get y is equal to 3. And that's what's known as the y-intercept. That is the point where your line is going to cross your y-axis, so 0, 3. Now we're going to find the x-intercept. To find the x-intercept, you're going to make y be 0. So now you're going to plug in a y in your equation, a 0 into your equation for y, and solve that and get a value for x. So we do that, and we get that x is equal to 3/2, or you could think of that as 1 1/2 for ease of plotting it. So that is your x-intercept. When y is 0, that's where your line is going to cross your x-axis. And then finally you pick a third point just for safety. You've used the 2 intercepts, the x-intercept and the y-intercept. And now you want to pick a third point for safety just to make sure you can connect all the dots in a straight line. Plot those dots, draw your line, and you're done. Finally, the third method is the slope in the y-intercept. For this, we want to convert our equation into, remember, slope-intercept form. So y is equal to mx plus b, where m, if you remember, represents the slope. Remember, the slope is sort of a measure of how steep something is. And b is the y-intercept. So remember that the y-intercept is where your line is going to cross the y-axis. So we take the equation, the same one that we've been using, and for this method we want to solve for y. So you have to do a little algebra work. We take our equation, and if we subtract 2x from both sides, we get y is equal to negative 2x plus 3. So now we have it in the form of y is equal to mx plus b. In this case, our m, the slope, is negative 2, and the y-intercept, or b, is 3. So just with those two pieces of information, we can draw our graph. And many students find this the easiest way to graph. So our starting point is always our y-intercept. So we're going to plot that point. Well, you say, well, there's only one number. Okay, but the y-intercept is where our line crosses the y-axis. So we go to where y is 3, and of course x is 0, and we're going to plot that. All right, now we need to use the slope to get us to another point. So our slope is negative 2. And we're going to write that as a fraction because you might remember that the slope is the rise over the run. So we need two numbers. We need to know how much we're going to rise or fall from this particular point that we've started at and how far we're going to run, forwards or backwards. So negative 2 we can write as a fraction as negative 2 over 1. And since there's a negative sign there, we're going to have to deal with it. Now, negative 2 over 1 does not mean negative 2 over negative 1. It means either you have negative 2 over 1 or 2 over a negative 1. And it doesn't matter which one of those that you pick. You're going to get to the same place. So let's just go with the first one, negative 2 over 1. So negative 2 is your rise. In this case, your rise is negative, so you're actually falling. So from your starting point, that y-intercept, you're going to go down 2 units, and then the bottom number, the 1, is your run. Your run is positive, so you're going to go 1 to the right, and that's another point. Now that same process you're going to repeat again using your slope. You're going to go down 2 units, and then over 1 unit to the right, plot that point. Now we have 3 points, and it's perfectly acceptable to stop there. Put your ruler down, draw the line, and you're done.